Find the integral of the function cos of x by 1 plus cos of x into dx. So we need to get started with trigonometric identities. So I'm going to make use of cos of 2 theta. How? That is a clue. First thing is I'm going to make use of this. That's your first clue. So you can pause and think over how is that we're going to replace all of this expression with cos of 2 theta. Okay. So cos of 2 theta can be written as what, guys? So cos of 2 theta, let me show it to you. So we have cos of 2 theta as cos square x minus sine square x, 2 cos square x minus 1, 1 minus 2 sine square x, and this. So what should we use? Yes, we can make use of 2 cos square theta minus 1. So if I rearrange this a bit, we have cos 2 theta plus 1 is equal to 2 cos square theta. So where to use what? In the numerator, I can make use of the first expression. So let me rewrite how exactly we can do so. I'm sure most of you would have done this problem, such problems wherein cos of x has been rewritten in some other manner. So 1 plus cos of 2x by 2, right? I can do this. So this is nothing but your theta. So this is theta and that is theta. So cos of 2 theta and 1 plus cos 2 theta. And that's how I can make use of the formula. So this is, we have integration of cos of 2 theta is 2 cos square theta, right? So this is x by 2 minus 1 dx, entire expression divided with 2 cos square x by 2. A bit of rearranging and we almost have the answer. So we have this to be 2 cos square x by 2 by 2 cos square x by 2 dx minus integration of dx by 2 cos square x by 2. So this is basically 1. So that's x minus half. And this is nothing but secant square x by 2. If you guys want to substitute x by 2 st and do it, that also is okay. Or if you want to do it directly. So integration of secant square theta is tan theta. But okay, let me keep it in a bubble. Forget about 1 by 2. Don't think about 1 by 2. Need this expression. But if I differentiate this, what will I end up with? So we end up with, if I differentiate this, we end up with secant square x by 2 into 1 by 2. Is it not? But here there's no 1 by 2. Actually there is. But let's not get confused with that. I'm just keeping that aside. So basically I need to have into 2 over here to eliminate this 1 by 2. So this is into 2. If I do this, I'll get secant square x by 2. Again, don't think about 1 by 2. Don't get confused with that. Okay, and plus a constant. Here too there is a constant. Okay, so we have this 2 and this 2 getting cancelled, and then we have x minus tan of x by 2 plus c. If you find this to be confusing, substitute x by 2 as t and so on and so forth. Then you'll get to know that 2 and 2 will get cancelled over here. It's okay. You don't have to think too much about it. This came out of chain rule. Of course, there's no chain rule per se over here, but that's how you have to think of it. Okay. So I'm trying to cut short the working because I want you guys to think in such manner. Don't take too many steps. That's what I'm trying to push you guys towards. If you find this difficult as of now, you can substitute x by 2 as t and you're done. That's my advice. If you're able to think of it, please try to think of it in this manner. Just keep this in the bubble. Keep whatever the coefficient originally is aside. Think of only that. And then you'll get to know that, you know what, we need to have a 2 over there. Because when I differentiate tan of x by 2, I'll get 1 by 2. To cancel that, I need a 2. So I'll write one more. To cancel 1 by 2. Not this 1 by 2. The 1 by 2 which comes out on differentiating. Okay, so I hope that made sense. Okay, you can pause and have a look.